this.
This should be reviewed. Okay? Yeah, you should know your parent graph. So guys, go ahead and make sure your packet's open to this. And we're going to go through these parent graphs and the domain and range for each of the parent graphs, okay? All right, so the first one here is y equals x squared. Do you know what that is a graph of? That is a parabola. That's okay. I am not going to want you making like a table of values to graph. We're going to graph all by transformation. But just in case you forget where these come from, if I plug a 0 in, it's a 0. 1 gives me 1. 2 gives me 4. Negative 1 gives me 1. Negative 2 gives me 4. So you should know those dots. We're going to write the domain and range. What do you think the domain is for that parabola? It is all real numbers. Same rules as last unit still apply for looking at domain. If there's not a fraction and there's not a square root, then you're just going to tell me all the numbers. Okay? What do you think the range is? All right, so we know that parent graph. Pretty easy. Okay. All right, x cubed. What does y equals x cubed look like? All sorts of arm movement, yes. So for points, again, you're not going to like make a table every time you do this, but just to remind you where they come from. 2, 8 is pretty much off the graph, and so it's 2, negative 8. You have to know these, yes. Yeah. But we're going to graph a lot with them, so hopefully, you know, just with practice, you know. All right, domain and range of this guy. Both going to be negative infinity to infinity, right? Yes. Remember when you're looking at a graph, domain is from the left to the right, range is from the bottom to the top. Okay. This didn't go well enough. We'll get through it, guys. You disagree? Well, every single word. Okay. That's fair. All right, let's look at the next one. Y equals square root of x. Do we know what a square root graph looks like?
It's like, man.
Yeah, this guy, right? It's just that. Again, you don't need the table. I'll write it for you just because. All right, so domain and range on this guy, not going to be all real numbers, so. Both 0 to infinity, right? Bracket, parentheses, what do we? Bracket, good.
Are they both 0?
Yep. All right, guys, next one, cubed root of x. What does a cubed root look like? Not quite. Sideways squiggle, yep, that's pretty good. It's kind of like the cube graph, but sideways instead of vertical, okay? So you still have 0, 0, 1, 1, negative 1, negative 1, but instead of 2, 8, it's 8, 2. What do you think for domain and range?
So mu has to be also.
Yeah. What about range?
Same.
Good. All right, so far so good. Kevin, is there something you can't read or this?
Yeah.
8-2. My line kind of ran into it. All right, let's look at 1 over x. Even if you don't know exactly what the graph is going to look like, do you know something about it?
No, 0.
Can't be 0, so what's going to happen at 0? Vertical asymptote. And I think we did too many, but yeah, the general idea.
Oh, it's like,
Yeah. I was like, wait, you just threw it in. Oh, okay. So let me draw in my asymptotes. There's definitely a vertical one at 0. Is there a horizontal asymptote? Yes, it is also at 0. Remember the whole bottom heavy stuff? Top heavy, bottom heavy equal for your asymptotes? You learned that this year, so you know. All right. Then, if we think about points, yeah, Ben.
What's the difference between an asymptote and a hole?
Well, an asymptote is like,
Well, like, I mean, like, finding it.
oh, finding it? A hole is when, like, if you have this, you don't have an asymptote, you have a hole at negative. Okay. And graphically, they look like you're okay with that. All right, so points for this. If I plug in a 1, I get a 1, right? What if I plug in a 2? What do I get? Okay, that's less fun. I don't want to keep going because I'm just going to get a 3rd, a 4th, a 5th. What if I plug in 1/2? What do I get?
2.
Yeah, okay. That's enough for it to follow the asymptotes on that side. And then if I, oh, go ahead.
so when in doubt, you just have to plug the numbers in to try and find it.
If I go on the left side, then -1 is going to give me -1. -2 will give me -1/2. -1/2 will give me -2. It's the same points. Okay. All right, the next one is weird. It is called a step function. Or sometimes the greatest integer. And I'm just going to draw it for you because it's just very weird. It always has, for the parent graph, a filled-in dot on the left. Okay. Then it connects over, straight line, open dot. Jumps up 1, close, slide over, open.
Oh, it's that weird one.
Is that weird one?
I mean, when you see that, it's usually just like, which one is not?
We won't do too much with this one, but you should at least do it somewhere. And you don't have to fill in the entire graph. Let me make it a little bigger. Just so you can see it. You can see it closed and open a little better. Oh, we skipped domain and range on the last one too. Let's do this one and then we'll go back. All right, domain. It looks really weird, but what is the domain? Wait, what? Why? Is it zero?
I'm talking about now, sorry, the one over X, sorry.
But isn't that filled in?
I'm talking about one over X, sorry.
Oh,
Yeah.
okay, sorry. So what about this one? What's the domain of that? Yeah, it's just all real numbers. You guys see every time there's a hole, it is like filled in by another x value in another part of the graph. So the domain is actually negative infinity to infinity. Now the range is weird. How would you describe the range? Not like notation or anything like that, just what are the
It's like
every integer. I like that. That's good terminology there. So you could say for the range, if you want to write it out, I would accept all integers. Or if you want to do proper notation, you would be saying y such that y is an element of the integers, which is like that weird C. Kind of like Zoro's coming.
What does D stand for?
Integers. Why does the weird R stand for reals?
Nobody knows.
I mean, that's just what they picked.
Is that a C?
Yeah, it's like, you know how we have this for reals? We have this weird Z. Technically, you could probably do it more like that. You don't have to overlap it quite as much as I did.
What's the second after Y?
Y is an element of integers. You know how with domain we were doing like x such that x is an element of the reals?
So Y.
Since it's range, we're doing y instead.
Y, find Y.
Element of integers. Okay. If you just want to write all integers, that's okay. And then let's go back to the previous one because I skipped domain and range on that. They're going to be the same thing. What are they going to be? Alva, you started saying it. Uh-huh. Yes. Okay. One more graph to go, guys. Just one more pair function. And this is one that you definitely should know from Algebra 2.
It's like the
It's the V, yeah, so it's like 0, 0, 1, 1, 2, 2, and then on the left side as well.
That would be 0.
For which one?
No range.
What's the domain? What?
Domain is
Domain is all real numbers, negative infinity to infinity.
the range is 0 to.
Yes, with the brackets. Okay. All right, guys, so those are the parent graphs, meaning those are the graphs you should be starting with, and then we're going to graph whatever equation we have using transformation of the parent graph, okay? So we're going to go ahead. That's not what I want. Sorry, I have this in like 2 files. This is what your next page looks like, right? Sort of. You guys get the page? Yes? Okay. All right, so let's go through our shifts and stretches and all of that stuff. Again, this is review. You've done it now for 2. We did it earlier this year multiple times, okay? So hopefully you know your shifting. So if the plus C is outside of the parentheses, like it's not in with the X, where am I going?
That's a lot.
Up, yes. What does that mean? The minus C is outside of parentheses. Okay, what about when it's plus C in parentheses?
You got it.
Left.
Oh, in the parentheses.
Okay. Isn't it in parentheses the minus? Right. All right, negative out in front. What are we reflecting over? What? Okay, I heard X and Y axis.
Nice.
It is the X. Because really, if it says negative f of X, that means your Y has changed sign.
Oh.
I never memorize this, guys. Like, this does not stick in my brain. So I just think about what it means. If it says negative f of X, that's saying negative Y, right?
Yeah.
So if your Y value goes from positive to negative, what did you flip over?
X.
Yeah. This one says negative X. If your X goes from positive to negative, what did you
A
reflect?
Y.
Yeah. Okay. I do not memorize that. Like I don't know. I just think about it. So this is reflect over x-axis. And this one is reflect over y-axis. Okay. All right. Then these last two. We've got the C just being multiplied out in front or multiplying the X. If it's out in front, what do you think that's doing? Okay, kind of. Is it a vertical or a horizontal stretcher compression?
Vertical.
Vertical. When it's outside, it's going to be vertical. When it's in with the X, that's when it does something horizontal. So out in front, I don't know the value of C, so I don't know if it's a stretch or compression. So I'm just going to say vertical, stretch, or compression. And then inside with the X would be a horizontal, stretch, or compression. So we will do much more with the vertical than we will the horizontal. The horizontal is trickier and messier and backwards from what you think it should be. You guys, you know how when it's inside, it's always the opposite of what it seems like it should do? Like when it says plus C, we actually go to the left. Okay, well if this says like times 2, it's not a stretch by 2, it's a compression by 1/2. Okay? When it's inside, it's always the opposite of what it seems like it should be. So if it said 1/3 X, what would that really be?
3 times.
Yeah, stretched by 3. Okay? All right. Now we get a graph.
Yeah.
Woohoo! Fired up. All right. We're going to graph not by plugging in values, not with your calculator, just by doing our transformations that we worked, okay?
Sweet.
So y equals x squared minus 1. Do you know your parent graph for y equals x squared?
No.
Parabola. We just did it. Yeah, it was just this, right? I'm just going to do those dots. What does the minus 1 mean? Down 1. So what am I going to do with each of those dots? Yep, down 1. If you have multiple colors, I would use them.
Wait, isn't this, where are you doing this?
We did this with some different graphs earlier this year. Remember? Yes. That's what I'm saying. This is not the first time you've graphed these figures. All right, and then I also said I want you to tell me the domain and range. So domain on this one should be easy. It's always going to be negative infinity to infinity. But what's the range this time? Okay. Now, do you have to do these dots in red? No, that's just kind of your guideline. Like, okay, this is where I started, and then I shift from there. And it's just there to help you, but it's up to you whether or not you use them. Okay. I want you to try 2, 3, and 4 for me. Then we'll reconvene and go through
So
them.
you have to do this exactly once.
Yeah, it has to be precise. Yeah. Okay. You'll have your packet with you, and I'm so. And this isn't too terrible, like you've seen this before, so. Don't take right to that man. So that's after And so number 4, is that a horizontal or vertical shift? It's a horizontal, good. It'd have to be like 1 over x and then plus 4 outside.
Do the other side.
Would it be to the right or the left? Underneath the drain? Would it be
Yeah, I mean, it's a horizontal shift, so it just says plus 4.
after what actually the
Yeah, so there's all that stuff we do.
complete,
So the difference with that.
Side is the
Yeah, so if it looked like, if it had been 1 over x and then plus 4 like that, that is up here. Yes. So I would always start with like, okay, I know my asymptote is like over here, 1, 2, 3, 4.
oh, so it's shifted over.
So everything shifts with it. Okay. Another minute here, guys, and we'll go through all of them. So, I think it's I'm not going to have you do every single one.
Oh, no.
I don't have a grade if I didn't have them with me, so they're not done. All right, guys, so number 2, if I'm thinking about the cubed graph, something like this, right? So if I go up 2 with everything, you guys agree that that's where I'm going? So that guy's way off the graph. Here, here, here. Right there. Okay. How do we do on that graph? Good. With this, you don't always have to have like that point that was 2, 8. That doesn't always have to show up, but just make sure your graph is reasonable. Like if you draw this and you end up with it like way, like yes, you go through those 3 points, but the rest of it doesn't make sense. If you're way too far out, you would lose points on that. Okay, so you don't have to have the exact point here, but you have to make sure your graph doesn't like go crazy outside of the points that you do have. Okay. It's 2, y. Okay. All right, so domain and range for the cubed ones, those are always going to be all real numbers. All right. Okay. Next one, square root graph. So I know my parent dots. And where am I going with this one? Right, left, up, down. What are we doing? Right. So right to. Here's my new graph. What's my domain going to be? 2 to infinity for the domain, right? Because it shifts right. And then what about range? Yeah, that one stays 0 to infinity. Okay. All right, I graphed for while you guys were working. Are you okay with that graph? We just shifted all left 4. Okay. So your domain would change because now it's -4 that we are jumping over. And the range is still 0 that we are jumping over. Okay.
Wait, is it domain? Is that
for a 3. That's a 2. It's very small too. Because we shifted right too?
Yeah.
Okay. All right, questions on any of those? All right, so let's look at the next section. Let's see. I do not want you to do all of these. Let's do 6, 7, 8. 9, 10. Okay. So let's skip a few in there. Yes.
That's massive.
Digging for things.
Yeah. Well, yeah.
Well, yeah.
I just got that yesterday.
The negative does open, I agree with that.
I would be one.
Where's the 2 line?
Where's the 4 ones?
Okay, what does the 2 do?
Thanks to the water.
Yeah, so when you go, instead of going like over 1 down 1, you're gonna go over 1 down 2. You're stretching it vertically. So
For me, it's like, so you plug in what, for example, so the one for, I should have flipped that one, so you do, you don't really want it. That's why I don't do that. I guess. So
Guys, I'm going to start graphing them just so you can check your answers when you're ready, okay? Check once you've got them done. How we doing? Okay, easy. Easy. Good. Graphing by transformation, I think, is so much easier than plugging in values. All right, how are you guys doing on the ones with the coefficient in front, like with the half or with the -2? See, all you're doing is multiplying the y values by whatever that coefficient is.
Wait, so why wouldn't it be a hard, like, parenthesis?
And which one?
Or,
Number 9? Okay, so do we include 0? Or is that where the asymptote is?
yeah.
Okay. So every time we're jumping over something, that's when we need the parentheses. All right, guys, when you're done with those, go ahead and turn the page. And then we're going to write some equations now.
Sweet.
Okay, let's do the first one together. So what we're doing now, you don't have to make the graph, but you just have to write the equation that accounts for whatever transformation we're talking about. So we're starting with f of x equals x, and I want you to shift 7 to the right and down 1. So f of x equals, how am I going to show 7 to the right?
Plus minus 7.
X minus 7 in parentheses, and then minus 1. There you go. Okay. Try 2, 3, 4, and we'll do 5. Try through 5, and then we'll go through those. You guys definitely make them equations. Make sure you're writing f of x equals. Don't just write the expression part of it. So yeah, if you're looking at the it would be outside of your shifting. You have to think back to that stuff. Okay.
Well, no, I was X. So Y would be. This way, anyways.
It's going to reflect over the y. That's where the x changes sign. So you have to put the negative with the x.
You didn't put it for the. Okay, then what about X?
Then it just goes like, I'll show you on 2, is the one we're talking about, right? Okay. Does that make sense?
It's the more shifting the Y axis.
It's inside with the x then.
Okay.
That's further down, right?
I don't know.
I think so. There's one down further. That's a little trickier, so we're going to talk about that one together.
Okay.
Very good. I'm going to keep putting these up here so you can check as you go. Well, the square root is like a grouping symbol, so like the x plus 6 is definitely under there. The plus 3 should not be included with it.
Let's go.
Doing great.
For cookies,
7, 8, 9.
Yeah, hold on. I guess I don't actually need parentheses on that one, but that's okay. All right, guys, let's check through 5 here. So then I want to talk about a couple others down below. Questions through 5.
Wait, so you can have x plus 5 all parentheses over 5?
No, because then that would be going left 5 instead of up 5.
Oh.
I like this one here.
Okay, yeah, this is easier than actually making the graph. Maybe not even easier, but just the other is like more focus.
I never liked drawing graphs. I never perfectly draw lines.
It's so hard. Yeah, I get it. All right, anything through 5, or should we move on? Okay, let's do 6 together. Okay, so we've got cube root going on, right? Okay, if I'm reflecting over the y-axis, that means my x has to change sign. So I know I have to have a negative x. And then to the right 8, you would say minus 8. But guys, that's not quite right. It has to be shifting once it's in factored form, so this is not the right way to do it. What you need to do is have the cubed root. Think about your reflection, and then deal with the shifting in parentheses. Okay? Do you guys see the details there? Okay? Because this one, if you factor your negative out of both of these, you would actually be going to the left 8, which is not what
So it's not on the X level.
not that one. This is the right way to do it. Okay? Eric?
Put the negative outside.
That would not, that'd be a reflection over the x-axis, not the y-axis. Okay?
Just put it there.
You can, but then this would need to be plus 8. Like if you want to distribute, that's fine. Yeah. It's kind of like when we graph trig functions. Remember you had to like factor out that coefficient sometimes to actually see the phase shift?
Yes.
Yeah, you guys look like you really remember that. You did that, I promise. Okay. All right, let's do 7, and then I'll have you do the rest on your own. So absolute value function in the vertex is at negative 3, 2. So that means you've gone left 3 and up 2, right? Okay. So that's all you're writing. So you're going to do absolute value left 3, up 2. Okay. All right, so try 8 through 11 for me.
What do you do for one graph? Have x squared.
For which one? Quadratic, yeah, that's x squared. Sorry.
I have a question about 6.
Okay.
So
With the negative.
I don't understand. So like, if you were to distribute the negative and you would know x plus
That would be right. Because you see the shift back from x. So that's why this is
Because if you're at the negative x plus 3, it would still go to the x plus 3.
factor on the negative.
Okay.
Because you want x to just be x.
Okay. Okay, thank you.
So that was weird. That's allergies. Are you sick?
Yes, I'm also.
Okay.
Like always say.
Yeah, Eric. related to linear function.
Like, we're only on 5%.
No, linear function is just a line, like y equals x. Okay. I think 9, even though it's technically the simplest function, I think that's the one you guys struggle with the most out of this group here.
They start way right after that. So like font or dot.
F of x is not that bad.
Linear X. That's a good one.
Alright guys, so for 8, you should have gotten f of x equals x minus 1 quantity squared minus 4. Do we need a minute still? Question, guys? The last one? Okay. So we'll talk about that. All right, the linear function whose 0 is 5. Guys, what that means is that 1, 2, 3, 4, 5 is over there. And there's your line. Okay? So, 2 ways you could write it. If you're like, okay, I see that that is shifted to the right 5, you could certainly do that.
Negative right there.
Isn't that exactly the same as just x minus 5? And if you think about your graph, it also is shifted down 5. Okay, like it works either way you look at it. Okay, it's kind of weird. All right, absolute value function whose range is -3 to infinity. That just means it's been shifted down 3. So you're going to have absolute value of x minus 3. Okay. All right, then the quadratic function whose range is -infinity to 4. What has happened there? Flipped, right? And what else? Up 4, right? If you're going all the way up to 4. So we flip over the x-axis. So where does my negative go?
Negative.
So outside.
Why is it -5
Which one? I'm sorry.
for 9?
Why is it -5?
Yeah. Oh,
Because we went to the right 5.
that makes
Yeah. Or down 5, either way you want to think about it. All right, does that make sense on the last one now? Yeah, we're okay there. All right. Okay, go ahead and turn the page. We are going to look at these little tables here. Okay. So let me explain what is happening here. So you've been given this little table with the values for x and f of x. Okay, and then these are the different transformations that are happening. I'm going to start with letter B just as an example. It says we're doing f of x plus 2. What does that mean? We're going up 2. So what would you expect to happen? What's going to change, the x values or the y values? Because if we're going up, that'd be y, right? And what do you think each of these would do? Go up by 2. So you're looking for the little table there that has -4, 7, -2, 3, 0, 8, 2, 4, 4, 9. You see it? Okay. So you are trying to match all of them. I will tell you letter A does not work. Like it doesn't actually match anything. So one of yours will be blank. Okay. So I'll give you some time. You can talk to each other.
I think one is 8.
And I think H and I are the hardest ones for you.
Wait, there's no surprise.
What?
H and J. Oh wait, those are H.
Yes.
I thought you were talking about on here. I was like, there's no I.
No, 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 no. Okay. I think there's a packet for you. Yeah. You understand? Okay.
So,
Yeah. Yeah. Okay, so this one. The doctor. Outside of that.
I got you, dog.
What? I reach it. Well, I'm saying that this thing, when it's not together,
That's cool.
So if you're going left, does that change?
oh yeah, because it doesn't affect, yeah. It doesn't change a lot.
So, something like this. So, second, you should look across the range.
The plus 3 users. Oh yeah. Because the other thing is
really all that means is literally every x changes. Negative 1 negative 2. They like.
Oh,
Whereas this one then is just changing the y they're opposite. Letter A doesn't have a match, so one of those.
okay. Was that next?
You have to use like every other word. See? The beliefs are not. Okay, so what does this mean? Okay, so the X is so. Another minute, guys, I'll show you the answers, and then we're done with them.
Thinking I had very this is too much today.
Too much today.
Oh,
I felt bad for the kids yesterday.
Well, whenever they're on,
Days, you're just not.
It wasn't today. I'd probably be a little more upset, or not upset, just to be like, wow, perfect. But like, it wasn't like too bad of a minute. Yeah, that was interesting. I say.
Yeah, not what it is. All right, guys, are you ready for answers?
I know I just did the review like the second time yesterday.
Oh, that's good. So you're probably ready.
Oh, bro.
All right, go ahead and check your answers. 7 was the blank. Again, I think the H and the I are the hard ones for you, but let's see how you did.
I mixed those up.
Did you mix them up?
I mixed them up too.
I'll show you why. I will explain 2 and 4.
And can you explain?
Yes, so see, that's the f of negative x, right?
Yeah.
So that's just saying your x's are changing sign. So negative 4 is going to become positive 4.
Oh, gosh.
Wait, C.
What is it?
It's like written in the reverse order though.
It's in parentheses, whatever is in there affects the x. When it's
Oh,
not, it
it's the
affects
same.
the y.
Yeah, so do you see how like this becomes positive 5? It's going to change.
I think that's the question. Judging me like so like if you're getting like this, a 1 against 2.
All right, should we look at H and I?
Yes.
Okay.
So yeah, that's you.
All right. Now, guys, H is saying f of 2x. So if you think about that, if I were to just leave like this column as it is and do 2x, 2 times negative 4 would be negative 8, right? Which is not really what I want. Like, that's not going to give me the same output. So what you need to think about when it's inside, it always does the opposite of what you think it should do. So look at this table. If I plug in a negative 2 into this, so what's 2 times negative 2? Negative 4, and negative 4 gives me a 5, right? Okay. 2 times negative 1, it's negative 2, which gives me a 1, which is this. Okay? Whereas this one, this is the one with the half, because if I plug in negative 8, what's a half times negative 8? Negative 4, which gives me 5. Okay? So anytime it's in with the x, it's always the opposite of what it seems like it should be doing.
So you're multiplying by 1 half. The negative 1.
Yep.
I'll do it.
Okay? All right, guys. Any questions? Okay, there is your homework. So in your packet, 2 through 18, that's the graphing, just for evens. 19 through 23, those are still graphing, but I give you like a weird parent function to do transformations with. Everybody see, the homework's like not front to back, it's like copied weird. So.
Maybe we could just find some box here.
Yep.